Dutch physicist, mathematician, and inventor Christiaan Huygens was an absolute genius. He could be one of the most influential and intelligent scientists to have ever lived. And one of the many things that he did was he looked at waves and he said, do you know what's true about waves? Think about this. If you have a pool of water and you just dip your finger in it real quick, you're going to create a ripple, right? That ripple is going to move out in a circular pattern because it travels at the same speed in every direction. But think about this. If there's another piece of water over here and you dip your finger in here and the ripple comes out and hits this spot, well, what does this spot do? This spot bobs up and down. Well, what does a bob up and down do? It creates a circular ripple. Well, Huygens said that every single spot that is vibrating in a pool where waves are moving through it are creating circular wavelets. And those circular wavelets overlap and interfere in order to create the wave fronts that we see. So a circular ripple is actually made up of, each little ring of that ripple is actually made up of a whole bunch of tiny, brand new circular ripples spreading out from each point. A straight wave moving along like you might see in the ocean or a wave tank is actually made up of a bunch of circular ripples, and they all overlap to create a straight wave through constructive and destructive interference. This is known as Huygens Principle, and it is an extremely important phenomenon. Huygens Principle can explain refraction without resorting to the crude waves are kind of like cars and the axle when the one part hits and slows down and the other. No, the wavelengths get shorter, the ripples travel slower in the other medium, and so when you have a wavefront hit, it naturally bends. There's no need to envision a wave like a solid object at all. It can also describe diffraction, the bending of waves around objects. This is another vocabulary word that you are absolutely going to have to know. Diffraction is the bending of waves around objects. And if you think about it in terms of Huygens principle, how diffraction behaves makes a lot of sense. If you have a very narrow slit, you end up with extremely circular wave fronts on the other side. If you have a very wide slit, then you end up with a flat section with ripples on the side, because the flat section has more wavelets next to it to interfere, but the ones on the very edge are just their own ripples with nothing to interfere, and so they stay circular. The general rule with diffraction through a slit is that the narrower the slit, the greater the diffraction will be, and the longer the wavelength, the greater the diffraction will be. So you don't see light waves diffracting through a doorway. Light waves have extraordinarily tiny wavelengths, and the doorway is really big compared to that. But sound waves are long. They can be 2, 3, 8, 10, 20 feet long. And so the wavelengths are big compared to a door, which is why it's pretty easy to hear people down the hall even when you're in the classroom. The waves hit the door and bend inside through diffraction. If I just put my hands in front of my face, you can still hear my voice because my voice is bending around my hands, but you can't see my face because the light waves, there is a little bit of diffraction right on the edges, but it's not enough for us to see because just light waves are way too small a wavelength. It's very noticeable with sound waves. It's very noticeable with water waves. It happens with light, but you need very, very tiny openings in order to see it.